All right. It doesn't, question. It'll be okay. You just borrow some paper, and then when I finish teaching, you can go grab it, okay? Yeah? So here's some paper. You got a pencil? Here's a bunch of paper for whoever. Yeah, hold on. I'll tell you all about it. Just a second. This is your lesson from Friday. I'm going to go back and just re-talk about it real quick because the weekend gets in between, right? I want to make sure we know exactly where we were, and then we'll add on, okay? So you don't have to write yet. You don't even have to look this page up. I just want to go over it so we're clear. On Friday, we were solving one-step equations. That means we saw one operation. And our basic plan of solving was to reverse that operation. Yeah? That's very quickly what we were up to. That is, my awesome equation solving plan said identify the operation that's been done, then do the opposite. As long as there wasn't negatives involved, we did pretty good. When there was negatives involved, got to think a little bit, okay? So negatives are really the problem. The plan didn't seem to be the problem. The negatives seemed to be the problem. Anyways, so I did a couple. I said, well, if it's multiplied by 4, let's divide by 4. Multiply by 12, let's divide by 12. Those ones I did both multiply. Then we talked about some ones with add, 157. So I did subtract 157. And there was different ways to write the answer. But basically, all we were doing was the opposite operation. That was the tricky one, right? Multiply by negative 17, divide by negative 17. And that can mess you up. Negatives can mess you up. I understand that. Here's today. Two-step equations. And some people jumped ahead and tried some of the two-step equation homework. So we're going to split the class in half today. I'm going to teach at the start, a little time to work, and then I'm going to teach again. You take out a piece of paper, write solving two-step equations. You can write it pretty big because you're going to want to look it up when you're having trouble. And up here, you write the date real quick. I've got September 9th. 9th month, 9th day. Do you need some paper? Always welcome. It's up on top of those cardboard boxes there. Take as many slices as you need. And if you need a pencil, I'll also deliver pencils. Pencils are over here. Do you need a pencil? Calculator? Snack? Oh, I don't have any snacks. Calculator? Pencil? No. Calculator? Pencil? What do you need? This is a nice, easy, simple one to use. Try that one.
Thank you.
Well, welcome. I'll put this pencil behind my ear just in case somebody needs it or in case I need to whip it at somebody. You kill a vampire with that. It's wooden. Just in case. Two-step equations. Okay. Like last time, the very first example, I'm just going to go ahead and do it. I'm just going to show you. Here's how you do these. And then we'll talk a little slower about the next one. Two-step equations. Say I've got 5x plus 13 equals 48. Now there's two steps to it. See, my awesome plan doesn't work anymore. Exactly. It sort of works. My awesome plan said identify the operations that are involved. You look and go, well, there's multiply by 5. There's also add 13, two operations, leaving one blaring question for this lesson. There's only one blaring question. Which operation do I undo first? That's the big question for the day. If we answer that, we could just go home. Which operation do I do first?
You do the plus 13 minus 13 from both sides.
She says correctly. She is right. She sees plus 13. She's going to do minus 13 from both sides. So don't let me rock your world here. I'm going to say something. I'm going to act like she's wrong. And then we got to fix what I say because I'm going to say something that's incorrect somehow. You're right. I'm wrong. Ready? Good. I see two operations. I see multiply and I see add. Doesn't BEDMAS say, let me write it down in red. Doesn't BEDMAS say to do multiplication before addition? But you said no. Deal with the addition first. And if you think I'm making a big deal about that, I am. This is the whole lesson in one moment. If we get this, and you understood Friday, we're clear. Why is she doing it in the opposite way? She's correct to do it in the opposite way. It's a good question. Let's go back to this. Step 2 in Mr. Todd's option plan, do the opposite. That's what equation solving is about, doing the opposite. So for us, when we run into 2 operations, we do the opposite, and I'm not making this up. Instead of using BEDMAS, no. We're going to do it in reverse. You can just do it in reverse. You can write down BEDMAS and go, no, I go this way now because I'm undoing it. Some people make this word. They go, not all teachers even show this. I'm going to just write it in reverse. SAMDEV. If you don't like that, you don't have to. Because lots of teachers just just do BEDMAS backwards. But I like SAMDEV. It's kind of catchy. It's just BEDMAS reversed. I just literally wrote the word BEDMAS in reverse. So then she says, okay, if I'm doing this in reverse, that means I take care of addition and subtraction first. I'm going to write that optional step. What color did I use for the optional step? Orange. Was it orange? Yeah, good memory. Here's the optional step. Some of you might like this. She says subtract 13 from both sides. Some people don't like that step. It just messes their brain up and they don't like how that looks or feels. So they just go, oh, it was add 13, so I move it over and I do subtract 13. And then you get your calculator out if you need it, and you go 48 minus 13. 35. Good. And what's great about this is, if you understood that, now we're back to a one-step equation. So our abilities in one-step equations come back. Now I got to do with multiply by 5. What's the opposite of multiplying by 5? Divide by 5. Now I do that divide by 5. A lot of people like writing this. They just divide by 5 on both sides, but you only have to do it on the one side if you want, and I get x equals 7. Hopefully you're like, huh, not bad. If you remember it being much harder than this, I know I've got 2 more things to teach you about equation solving, but I'm taking them on purpose, slowly, yeah? Because we got a lot of equations to solve this year, and we want to be very good at them. We want to be looking and go, bang, bang, no problem. Over here, if you didn't write a box, that's okay, but over on the right-hand side, here's one for you to try. Let's find out where we're at. Because if we've done it just right, if I've done my job and gone slow enough to build your confidence, and you've done your job practicing on Friday, maybe this will be pretty straightforward. Let's see. 3x minus 14 equals 49. I've tried to make the numbers big enough that no one's really going to do it in their head. Take a second and try it. If it goes wrong, we talked about this. When it goes wrong, it's the best chance you got at learning. Yeah? You do it wrong, and then we fix it, and we go, oh, I get that now. I got it. Try it. See how you do. If it goes badly, we'll fix it, and you will learn. Oh, wait, what calculator did you grab there? I want you to have a good one. Is it a good calculator? No, that one's so-so at best here. I've made a big mess here. I got to clean this up. Ah, this is a good one. This is the one to borrow when you're going to borrow one. Real nice. I know they look sort of the same, but that, I'm just telling you, some of them are nice and some aren't so nice. I got another one. Does anyone need one? Calculator? Xavier? Try it out. Oh, I like this class. When I say try it out, you all try it out. Last year's class, sometimes people just sat there. This is much better. You're making me happy. Actually, I got to do attendance too, don't I? I'll get that up on the screen while you guys are having time to finish that. Return to sign-in page. Very good. That's not what I wanted to do there, no. There, okay. Okay, I don't want to rush you, but I don't want to bore you. Who'd like some more time to make sure they get that thing? You want more time? Okay, take more time, yeah, good. This is important. If we get this one, we're pretty much in the clear for this part of the lesson. Yeah, you're all over it, eh? Yeah. Fill up your cup. Let's see who's away today. Ooh, everybody's here. Okay. We got a full week of perfect attendance. Mr. Todd's buying the treats. This is not for you. I will erase that so you're not confused. Who still wants more time? You ready? Okay. What operations do you see? Did you hear me hesitate? I want to ask just the right question. What operations do you see?
Subtraction.
You see subtraction. What's the other operation you see? I got to deal with multiplication and subtraction. Which one do you want to go after first?
Subtraction.
Yeah, subtraction to become addition. I'm going to try and rock your world. Get ready.
Yeah.
I'm going to try and mess you up. Then you fix it, okay? But doesn't BEDMAS say that you do multiplication before addition and subtraction? Why are you doing the addition and subtraction first? He's not sure. He knows it's the right thing to do, but he doesn't quite have the words yet to explain why that is the right thing to do. Can anyone help and explain why, in this case, we're not doing BEDMAS? We are actually doing BEDMAS, but what's happening in equation solving? There's one word that we need from Mr. Todd's awesome guide. What's the word on the page here? Opposite. Because we're equation solving, we're doing the opposite. So instead of doing BEDMAS, we go backwards. Yeah? So we go after subtraction first. Now, which way did you do it? Did you just move it over? Or did you put plus 14 on both sides? I like this, actually. I know I'm putting it in orange, and maybe some of you think that's because I don't like this step. I actually do like this step a lot, because it reminds me what it is I'm doing with equation solving. I'm adding 14 to both sides. That way it stays equal. Yeah? But if some of you didn't learn it that way, or if that's not the way your brain's quite wired, that's totally fine. Maybe you're jumping right to the blue step. Then most people, not everybody, needs their calculator then. 49 and 14. 63, I heard someone say it out loud, 36, 3x equals 63. And now it's back to a one-step equation.
Divide both sides by 3.
Divide both sides by 3, and I get x equals, did you punch it in?
0.0476.
Oh, I think you just divided the wrong way around. You said it, but you typed it in the wrong way. 63 divided by 3. Try it again, type it in. And that's a common thing. That's why we're doing these together. So that we go, oh, right, I got to divide it that way.
21.
21. I'm not saying you can't get crazy decimals in an answer. We can. Sometimes the answer is a crazy decimal. Lots of times in this chapter, I keep the answers so that you see I've been making them so they come out nice. But they don't have to. The world doesn't have to be nice. But I'm sort of nice in this chapter as we learn how to do these. Okay. Mr. Todd's awesome equation solving plan. If you're like, we already did that. Yes. If you want to go back, if you got the old one, you can go back and just change it. But I am going to make it even awesomer. I'm going to sort of shorten the words, but add how to deal with this. So 1. Check what operations you see. That's the same as the old step. The only thing different is check what operation. I'm going to put a little underline, yes. Operations you see. And then step 2, I'm just going to change the words a little bit for my plan. I want to keep the plan short. Use reverse BEDMAS. And again, if you like my fancy word, you can have it, but you don't have to. The fancy word is SAMDEB. There's nothing fancy about it. It's just BEDMAS written backwards. SAMDEP. Some people like that, like having the fancy word.
Can I go to my waffle?
Yeah. To do opposite operations. I'm just going to add a couple more words. One at a time. Is it possible to get so good at these that you do multiple steps in one level? Yeah, but that's a long way away. I don't think grade 10s or 11s or even 12s generally do that. They generally do one thing at a time per line. Okay? Do you agree that that's pretty much the same plan I wrote before? Check what operations you see, then use reverse BEDMAS to do opposite operations one at a time. Is there three-step equations? Not really, not like that. They look different, and we'll do those later today, or maybe tomorrow. We'll see how it goes. There might be variables on both sides. There might be brackets to deal with. So we'll do those a little later. So I'm almost done this part of the lesson. I like the idea of breaking this into 2 lessons. Do a little bit now, do a little bit of the homework, and then maybe I'll teach you a little bit again, maybe about the 1 o'clock time. If you already did the homework for today, well, I've got a practice sheet for you. Don't worry, I'm ready this time. I got your assignment ready. This guy, ready. Well, sort of orangey, really, more than ready, am I? Do you need more time on this slide? All right. 2-step examples. My job to make up 3 examples we can do. 1, not too bad. 2, a problem that might come up. And then 3, you better know what you're doing. All right? Ready? Okay. Here's my first one. M over 5 minus 12 equals 8. I've only changed it from the previous example by a little bit. This one's supposed to be only 1 step more difficult than what we are already doing. Can you name Mr. Todd's awesome plan in your own words without peeking? What's step 1? What do we do first? It's the awkward pause as we wait. First, we get some Kleenex and we start crying about the equation. No. First, we check what operations we see. What 2 operations do you see in this 2-step equation? Division and subtraction.
Multiplication and addition.
He knows we got to do multiplication and addition. Which one first? Adding. How did you know? Oh, yeah, he knows. He's probably too good at it. That's probably what happens. He's like, I just know which one to do. We do reverse BEDMAS. Yeah? Instead of doing multiplication then addition, we deal with addition and subtraction first, then we do multiplication division. So what's the opposite of subtracting 12? Adding 12. Good. Okay, so here I go. I forget, what was it? What was my optional step color? Orange? Some of you might like to write it like this. You go, okay, so I want to do the opposite of adding 12. So I'm going to add 12 to both sides. And over here, negative 12 plus 12, those cancel. That's why we do those operations, our opposite operations. And then 8 plus 12 is 20. By the way, sometimes opposite operations is called inverse operations. We don't need to call it that, but you might see it called that sometimes, inverse operation. Then what do you see? Yeah, cross multiply. See this divide by 5? Now bring that over and make that 20 times 5. Can anyone do that in your head? 20 times 5 in your head? 100. Yeah, maybe there's some we can just do in our head. Okay. Remember my goal. 3 examples, each one. Actually, I don't know if harder is the word. It's just me up here going, what might they have difficulty with? What might go wrong here? And so here's the one that might go wrong. If you get that, you understand the point of the lesson, you're in good shape. Here I come to mess you up. Let's make sure we understand what I did. What did I do here that is going to be the problem? It's not really a problem in our method, but it's going to cause problems. It causes people problems. What is it? There's negatives in there now. Okay? So we got to watch out for that. What operations do you see? Subtract the 47. And then what's happening here? When a number's beside a variable like that,
Yeah,
it's multiplying, yeah. So which one are we going to deal with first? The subtraction, because we want to do reverse BEDMAS when we're equation solving. So we're going after subtraction first. Feels weird, but that's what we're doing. So after all that, the million-dollar question is, what's the opposite of subtract 47? And you like the extra step, if I remember right. I'm writing it every time. You can choose. So I'm going to add 47 to both sides. But then I let my calculator take over. And I type in negative 82 plus 47. And those of you who hated negatives last year, you're like, wait a minute. As long as I just have my calculator, I don't have to be that scared of negatives. I just have to know where the negative button on my calculator is. So you try it right now on your calculator. Type in negative 82 plus 47, and what do you get? Negative 30. Punch it in one more time to check. 35, good. So maybe, just maybe, because we had time, we've got some time to think now. It's like, wait a minute, me and negatives aren't great friends. I got to tell you. But with my calculator available, I can manage. I can get through this and move on to something else as long as I know how to type it in. Now he said it was multiplied by negative 5. What's the opposite of multiplying by negative 5? Divide by negative 5. And then again, it's a typing in problem. Negative 35 divided by negative 5? 7. Negative divided by negative is positive. Yeah? One last, and then we got some work time. If you've done your work already, because you're a step ahead of us from Friday, I've got your chapter assignment ready and you can start working away on it. Aren't you excited? No. She says no. Maybe we need to change how we look at assignments. To you, assignments is more work. To me, assignments is, here's a way to build up marks where it's not the test. Yeah? Well, I got stuff to mark, that's true, but that's not the point. The point is, as you move through the classes, move through the grades, assignments and quizzes are the things we go, this is how I build up my mark. So if I'm not really a test person, and tests don't go great for me, this is how I make sure everything's going to be okay. Because I can use my assignments to build up my mark. And I can ask Mr. Todd questions about the assignment. I go, ooh, what about this one? I can ask a friend. Not cheating, asking for help. Right? All right. Last one. What am I worried about here? What am I worried about? 17 plus 3x equals do. 45. Yeah. Just watching out for things. You might not think there's a big deal going on here, but this could mess you up a little bit. Maybe not. What operations do you see? Addition. So we're adding 17. I know it's backwards. Yeah, that's how I was trying to mess you up. It still adds 17 though. But it's just adds the 17 is just in front, that's all. And then what's this? Multiplication by 3. So what I'm going to do is subtract 17 from both sides. And if this is really upsetting you, if you're really having trouble, I'm going to show a slightly different way to do the green step. Or sorry, the orange step. Some people love this. Yes? Instead of writing on a separate line, I just go like this. I just write minus 17. Whoops, it didn't even come out right. I just write it right there. That really helps some people's brains. They just go, oh, I see what you're doing now. I'm just subtracting 17 off both of those. 17 minus 17, that's all gone. And that manages that just a little easier for some people. And what's 45 minus 17? 28. And what's the opposite of multiplying by 3? Divide by 3. So I'm going to go 28 divided by 3. And what's 28 divided by 3? 9.33333. That's the first one like that, eh? Yeah. So I want to talk about this just a little bit. I'm going to tell you for today, I'm okay with either answer. But as we go along, we better talk about which answer do we like better. Do we like the decimal? Do we like the fraction? The answer to the question, I'll give it away right now, is it depends on what's going on. It really will depend on what's going on. There is lots of things in this world where the decimal will be fine. And then there's some things in this world where we'll want the fraction instead. We'll just leave it. Once it goes decimal, we're like, no, we'll just leave it as a fraction. Okay? So those are both good answers. We got to talk about that. Which one's the better one? Okay, so what you have is, yes, our Friday's homework sheet. Let me just find my copy of it. At the top it said one-step equations. At the bottom it said two-step equations. I'm going to give you about 15, 20 minutes to do the two-step equations. Then I'd like to take them up and make sure we got them, because we seem to be a good taking up class. It works good if we take them up afterwards and go, okay, I got those. If you don't have one of these sheets, I will bring it to you and you can work on it. Yes? If you're all done the two-step equations, maybe you'd like the assignment to start working on the assignment. Fair warning, assignment people. If you finish and you want to start working on the assignment, fair warning. I've only taught the front page, not the back page. So you can only do the front of the assignment. Have you ever done one of these riddle sheets before? No. If you never have, when you pick it up, that's why I'm not going to deliver it. Normally I would deliver it. I'm not going to deliver it. I'm going to put it right up here. When you pick it up, you say, Mr. Todd, how do I do this? Not how do I do the math. How do I do the riddle sheet? Because it's hilarious, let me tell you. It says, what's the title of this picture? And the answer, you are going to laugh so hard, you're going to spit your lunch up. No, they're not all that funny. They're like dad jokes. But at least when you get the dad joke and you go, that's stupid, at least you know you got all the math right. That's what's nice about it, okay? Here, look, I'm right on my watch. I'm going to set a 15-minute timer. 15 minutes to work on the two-step equations. If you're done those, start working on your assignment, and then I'll start looking for people to be sharers. We good? All right. I'll do attendance, post that part of the video. Yes.